All right. Math 1, practice 2.1.4, function notation and evaluating functions. So let's take a look at these guys. So remember a few things we're talking about here, okay? The first is function notation. So there are a few things to think about when we're dealing with the function notation. Okay, and the thing to remember that the format is a letter followed by a variable in parentheses. Okay, and we read it f of x or g of x or r of x. Okay, and that f of x together represents the output. So normally when we did a table we did x and y. Okay, and for example on number 1 we'd have 1, 0, 1, 3, and 8 for our x's, and our y's would be the outputs. But with function notation we replace that y with f of x. So that whole f of x represents the output, okay? And this f or g or r just tells us the name of the function. So I can put more than one function together and know between them. So we have f of x, so that's our output when our input is the variable in between, in the parentheses. Okay, then it's equal to just our equation, the pattern. Now we don't really do anything with this part. We don't solve for it or anything like that. Now typically when we're evaluating or solving for them, we take those input numbers, so f of, and we replace the x with the number we want to put in, so f of 0. And then every time there's that same variable in our equation, we replace it with what's inside the parentheses. Okay? Then this part represents the output when the input is 0. So we don't deal with that anymore, and we save that till the end. And then we'd go 2 times 0 is 0, 0 minus 8 is negative 8, so that's my output. So when I have an input of 0, I have an output of negative 8. An input of 0 gives me an output of negative 8. So I'm going to do that for every single one of these inputs. So I go f of 1 equals 2 times 1 minus 8. So 2 times 1 is 2 minus 8 is negative 6. So f of 1 equals negative 6. That's like the point 1, negative 6. In my table, input of 1 gives me an output of negative 6. Okay, and that's all I do. So now I do it for 3. F of 3, notice how I'm always changing that input when I'm evaluating. 2 times 3 minus 8. Notice that whatever goes in for x goes in for x in the problem. So 2 times 3 is 6 minus 8 is negative 2. So f of 3 equals negative 2. Input of 3 gives me an output of negative 2. Okay, and then that last one, 8. So f of 8 equals 2 times 8 minus 8. 2 times 8 is 16, minus 8 gives us 8. So f of 8 equals 8. Input of 8 gives me an output of 8. Okay, so what would be my range then? My range is all the outputs, all those y values, as we often call them. The f of x stands for that output as well. So I'd write them in those same cool little fancy brackets, because that's how we write sets of numbers. I'd go negative 8, negative 6, negative 2, and 8. And that's really what the answer wanted from me. That table can be very helpful in us solving these. Okay, so let's take a look at number 2 now. Okay, so let's make our table. So now we've got gx and g of x. So our domain, 2, 4, 6, 8. So 2, 4, 6, and 8. Okay. So then there's g of x, there's my function, and that's what it looks like. So now I'm going to plug these numbers in. So I've got g of 2 that I need to figure out. I've got g of 4 that I need to figure out. I've got g of 6 that I need to figure out. And I've got g of 8 that I need to figure out, right? So then I look at my pattern and say every time there's an x, I put my number in for the input. So it'll be 2 minus 13. 2 minus 4. Oh, 13. Where did 13 come? Oh, crap. Hold on. Let's try that again. 2 minus 13. 4 minus 13, 6 minus 13, because I replaced my x with what I put in the parentheses, 8 minus 13. And then I just solve this side. I don't touch this side. That just jumps down, and that's part of my answer. Okay, 2 minus 13, negative 11. 4 minus 13, negative 9. G of 4 equals negative 9. So at 4 we have negative 9. At 2 we have negative 11. Okay, G of 6 would be negative 7. So an x value of 6 gives me a y value of negative 7. An input of 8 gives me an output of negative 5. Okay, so there's my range. Negative 11, negative 9, negative 7, and negative 5. Now remember, with domain and range, the domain is all the x values, the range is all the y or f of x values, or g of x, or whatever. Okay, and we got that one done. So hopefully you're seeing that same pattern when you're dealing with evaluating these. Okay, so now let's do it for f of x equals 3 to the x plus 1. Notice we've got an exponent there, so it's going to be a little tougher. We've got our domain here, so what are we finding? Well, we've got x and f of x. Our x values are 1, 2, 3, and 4. Okay, so we go f of 1 would equal 3 to the first plus 1. Okay, so my input was 1, so I changed my x to 1. 3 to the first is 3, plus 1 would give us 4. So when I have an input of 1, I have an output of 4. X of 1, a y value, or f of x of 4. Do the next one. F of 2 equals 3 squared plus 1. So, because we change them. 3 squared is 9, 3 times 3. 9 plus 1 is 10. So we get 10. Then, and that's what f of 2 is equal to. Then we do f of 3. 3 cubed plus 1. 3 times 3 times 3, or in other words, 9 times 3 is 27, plus 1 gives us 28. So f of 3 equals 28. Okay, then the last one, f of 4 equals 3 to the fourth. Well, 3 times 3 times 3 was 27, times 3 one more time gives us 81. Plus 1, we get 82. So f of 4 equals 82. Okay, so then, once we've evaluated all those, it wants our actual range. So looking at the y values, or the range values, the f of x values, we do them in our cute little brackets, and we go 4, 10, 28, and 82. And then we've got that one. Okay, number 4, same idea. We've got r of x, we've got x and r of x. Okay, is 2 to the x minus 1. We've got 0, 1, 2, 3 for our inputs. Okay, and we want to find the range, we want to find our outputs. Okay, so I go r of 0 would equal 2 to the 0 minus 1. Now, anything to the 0 power actually equals 1. Kind of a weird idea, but it's a rule. So we get 1 minus 1, which is 0. So r of 0 equals 0. So if I graph that on a graph, it would be at the 0, 0. Then we do r of 1. Okay, 2 to the first is 2, minus 1 is 1. So r of 1 equals 1. Okay, now you may want to say 2 is going to be 2, but let's double check. R of 2 equals 2 squared minus 1. 2 times 2, or 2 squared, is 4. Minus 1 gives us 3. So r of 2 equals 3. So that I didn't work, did it? Okay, then we do r of 3. So that would be 2 cubed minus 1. 2 times 2 times 2 is 8. 8 minus 1 is 7. So r of 3 equals 7. Okay, so our range for r of x, 0, 1, 3, and 7. And there's our first 4. Okay, now, like I said with that function notation, the number inside the parentheses represents our input, or our x value, and what it's equal to represents our output, or our y value. Okay. So in other words, looking at this, we have x and f of x. So x is negative 3. Well, what does f of x equal? Well, let's look on our graph. We're looking at negative 3, so go to negative 3. Where's our graph at? Our graph's down here. So this is our point where we have the x value of negative 3. Well, what's the y value? It's negative 8. So it would be negative 8. So what is f of negative 3 according to this graph? It's negative 8. And that's all they wanted you to do on this one. Okay? Alright, so taking a look at 6, same idea. The graph of f of x below, what is f of 2? So x and f of x. So if we have 2 for x, what's our y value? Well, go to 2 on our x value, jump up to our graph. So that would be 2, and then our y value would be 3, so it's 3. So that's what it is. F of 2 equals 3. Our x value, our y value, or our f of x value. Okay, number 7. A growing company has been hiring employees at a steady rate of 1 new hire per month. The company started with 2 employees. The growth of the company can be modeled with this function, where x is in months. Evaluate the function over the domain 3, 6, 18, and 24. Interpret the results and use a graph to explain your answer. So let's do this over here. So we've got g of x equals x plus 2. We've got our domain, which is 3, 6, 18, 24. Okay. They want us to evaluate it to find our range. Okay, so in other words, x and g of x, so we've got 3, 6, 18, and 24. And then they want us to talk about it as a graph, right? Maybe I need to make my graph a little bigger, huh? Because we're going clear up to 24 on our x. So we've got 3, 6, 18, and 24 are the ones we are paying attention to. And then we'll have our go to 25. Okay, so now with our function, we need to evaluate it for each of these. So I'd have g of 3 equals x plus 2, so 3 plus 2. 3 plus 2 is 5, so g of 3 equals 5. Okay, then g of 6 equals 6 plus 2. Because we replace the x with 6. 6 plus 2 is 8, so g of 6 would equal 8. So if I wanted to, I could graph those, couldn't I? Without even making that table. That would be 5 and 8. So 3, 5, and 6, 8. So it's 3, 5, 6, 8. Okay. Now let's do it for 18. And hopefully you've noticed the pattern and may not even need to write it out like this. But if you need to, here you go. Alright, so 18 plus 2 is 20. So g of 18 equals 20. And we get 26. So g of 24 is 26. So then we graph 18, 20. So 18 and 20 would be about right here. And then 26, right? So 26. So 24 and 26 would be like right up there. Okay? So there's a few points of our domain and range. So then it wants us to interpret the results and use a graph to explain your answer. So my results are here. So in 3 months, they have 5 total employees. In 6 months, 8 total employees. 18 months, they have 20. 24, they have 26 total employees. Okay. So however many months they've been hiring, they have 2 more employees than those months. So if we really wanted to, we could try to draw the graph. I don't know if it'd work that well to do that. There's our range. But that's the idea. It tells us how many employees based off the months. Okay? So all those were part of the answer for number 7. Okay? Alright, let's take a look now at number 8. The population of insects doubles every 3 days. The population started with 8 insects. The function that models this growth is f of x equals 8 times 2 to the x divided by 3. Okay? Evaluate the function over the domain 0, 3, 6, and 12. Okay? So, interpret the results and use a graph to explain your answer. Alright. So, kind of a crazy looking graph. So, we've got f of x equals 8 times 2 to the x over 3. Okay, now that x divided by 3, normally we don't have a fraction, but I think what that is basically telling you is that if you went to 3 days on the x's, 3 over 3 would equal 1. That's our first set of 3 days. So kind of how I said to just write your graph as or your table as the first of, this is a way that we can kind of deal with that. So what was our domain? 0, 3, 6, 12. 0, 3, 6, 12. Okay, so 2 ways we could write our graph. You could go 1, 2, 3, 4 with the idea that this would be our domain's 0, this would be our domain 3, this would be our domain 6, and this would be our domain 12. Okay? Either way you deal with it, you'll get the same thing. Let's just use their numbers for this time. But I just wanted to draw that connection for you guys. So 0, 3, 6, and 12. So then we start to plug them in. F of 0 would equal 8 times 2 to the 0 over 3. 0 divided by 3 is 0. 2 to the 0 is 1. 8 times 1 is 8. So f of 0 equals 8. Then we do f of 3 equals 8 times 2 to the 3 over 3. 3 over 3 is 1. 2 to the first times 8. 2 to the first is 2 times 8 is 16. So f of 3 equals 16. Okay, so after 3 days we've doubled, right, to 16. Then 3 more days, which would be 6, we should double. That should be 32, shouldn't it? Well, let's test. Okay. So, f of 6 would be 6 divided by 3. 6 divided by 3 is 2. 2 squared is 4. 8 times 4 is 32. So f of 6 would equal 32. See how I can just kind of like adjust a few pieces of my graph and or my evaluating because it's the same process. Okay, f of 12 would be equal to 8 times 2 to the 12 over 3. 12 divided by 3 is 4. 2 to the 4th is 2 times 2 times 2 times 2. So that would be 4, 8, 16. So 8 times 16, what would that be? 8 for 128. So f of 12 equals 128. Now you say, well, that's not doubling. That's because we left out a domain of 9, right? If 32 doubled, it'd be 64. 64 doubles is 128. So that's why they skipped that 9 days. So what does that mean? Once again, interpreting the result, we started at 0 days. We started with 8, what are they? Insects. Okay, we started with 8 insects. Okay, then every 3 days they doubled, so after 3 days we now had 16 insects. 6 days we had 32. 12 days we had 128. Okay, if we were to try to graph that, it would look something like this. There's 12, 9, 6, and 3, and 0. Okay, for our other ones, we'd be going up by, so if that was 8, there'd be 16. That would be 32, roughly. then 64 would be like up here, and 128 would be even higher. So 0, 8 is where we'd start, 316, 632, 964, even though we didn't do that one, and then 12, 128, so it would be going up like this. Okay? There we go, so that's number 8, what you guys should have answered. And then talking about like this, I just used it verbally, but you'll need to write that down, about what these meant and what the range meant. There we go. Alright, number 9. Okay, so a postal delivery service charges $3.40 per package, and then an additional 50 cents per ounce the package weighs. The function can be modeled like this. Starting number, right, 340, then we're adding 0.5 per ounce. Tom ships 4 packages with the following weights: 2 ounces, 3.5 ounces, 15, and 21.3. Write 4 statements using function notation that evaluate the function given each of these weights. Interpret the results in terms. So what they want you to do is go, basically, f of 2 ounces is equal to what number? F of 3.5 ounces is equal to what number? F of 15 ounces is equal to what? And F of 21.3 is equal to what? Okay, so we just have to evaluate it. So let's give us some space to evaluate. Okay, so looking here, here's our function. Here's our numbers. I'm going to grab a calculator to help me with this one. So we go f of 2 equals 0.5 times 2 plus 34. So 1/2 times 2 is really 1, right? So we'd have 1 plus 34, or 3.4, right? So it'd be 4.4, which we're talking about money, so it'd be $4.40 for 2 ounces. Okay, then we do it for, leave that as x, and we're going to change our 2 to 3.5. Okay, so I'd go 0.5 times 3.5 again, which gives me 1.75. Then we add 3.4 to that, and that gives us 5.15. So 3.5 ounces, it's 5.15. That's how much it would cost. Now we can do it for 15 ounces, so let's erase our numbers because it's the same process. As you can see, I'm using the same exact process to evaluate a different number. So f of 15, we get 0.5 times 15, which is 7.5, which this is I'm using my calculator for, plus 3.4 to that 7.5 gives us $10.90, 10.9. So for a 15-ounce package, you'd spend $10.90. And I'm kind of interpreting the results as well. The input was the ounces. The output was the cost. Okay? And that's basically the best way to interpret it. Okay? So last one, 21.3. So let's erase our 15. And you get a lovely bell in there just for funsies. Okay, so using the same function, we evaluate 21.5 or 0.3. So 0.5 times 21.3 is 10.65. Add 3.4 to that, we get $14.05. So a package of 21.3 ounces is $14.05. And there we go, guys. Okay, last one. So an investment promises a return of 12% per year. That's high. Brody wants to figure out how much money he will have if he invests $1,000 for 5, 10, or 15 years. The investment's growth can be modeled with this function, 1,000 times 1.12 to the x. Write 3 statements using function notation that evaluate it, okay, and interpret it. So these represent our inputs, right? So f of 5 will give us a certain amount of money. F of 10 will give us another amount, and then f of 15, a third amount. Okay, so our input is the time we're putting our money into this investment. The function, when we do that, will then tell us how much we'll get out of it, which is our y value. That's the amount you would earn after that amount of time. Okay, so let's put these in. Alright, now remember, looking at our function here, okay, our inputs 5, 10, 15, they're going to go here. And this function follows that investment. Because it's 12% for each year, we're adding that 12% to our 100%. That's 112% in growth. That's where we get the 1.12. That's what this number comes from. So, but let's plug them in. You didn't need to know that to plug it in. So we put 5 in, and we're going to evaluate. So the 12 becomes 5. So once again, I'll use my calculator. 1.12 to the 5th equals 1.76234163. So I'm just going to leave that in the calculator and then times it by 1,000. So we'd get 1,762 and 34. Since we're dealing with money, we round at the nearest hundredth. Okay, so 1762.34. Alright, now let's do it for 10. So 1,000 times 1.12 to the 10th. So I'm going to type that in my calculator again and then just come up with the answer, because it's a lot easier that way because of the numbers that we're given. Okay, so 1,000 times 1.12 to the 10th gives us 3,105.85 when we round. Alright, so just doubling our years gives us a pretty good amount, doesn't it? So 3,105.85. So once again, our input is the years we have in this investment. Our output is how much we'd be making after that. So let's do one more with 15. So f of 15, we use the same format, same pattern, just change our input to 15. So then I type it in my calculator again, and we get $5,473.57. Not a bad investment. If you have $1,000, you know, you make quite a bit more just by leaving it in there. Okay, well, there we go, guys.